So we have to find the derivative of f of x equals the square root of x. I give you the graph right here. It wants us to find the slopes of the graph of f at the points 1, 1, and 4, 2. So we can kind of look at 1, 1 right now and see that maybe, I don't know what that's going to be, but positive some sort of fraction less than 1, right? Maybe 1/2 or something. 4, 2, so here we are here, and then also positive less than 1, I don't know. That one kind of looks like 1/2 to me also, so maybe one of these will be 1/2, I don't know. But then we also want to discuss the behavior of f at 0, 0. Just by looking at the graph, what do you see? Or if we're going from the positive side, that would be where it ends, right? Okay. What would the slope be of the tangent line there? Yeah, like if I take the limit as we approach here, what would the slope be? Does it seem like this could go to a vertical line? So it could potentially have a vertical line as a tangent line, which would mean it had an infinite slope. In other words, an undefined slope. Maybe. Or maybe not. Maybe it doesn't quite go vertical there. So that's why we want to discuss the behavior there, because we're not sure. We don't know what happens here. Okay? If we wind up with division by 0 when x is 0, then yeah, it would have a vertical tangent line, an undefined slope. Okay? All right, so find the derivative of f of x equals the square root of x. Let's do that first. I'm going to write what? Good? Good? Okay. So what are we going to have to do to simplify this? Rationalize, yeah. We have 3 techniques, right? Direct substitution, which we know won't work because of the division by 0 right there. So if I plug in 0 up here, I have square root of x minus square root of x, which is 0. 0 over 0 means I can divide something out, right? So I need to either use the dividing out technique itself or the rationalizing technique so that I can divide something out. And with these square roots up top, it's going to be the rationalizing technique. So how do I rationalize this? Conjugate of the numerator is? Yes? Good. Over the same thing. It has to be a fancy one. Can't be a regular one. It has to be fancy. That's a 1. Not changing anything here. Okay, what do I get? Equals the limit as delta x approaches 0 of, you do have to rewrite that every time. We're foiling here. This is that times that. First terms is the exact same thing, so that's that thing squared. Square root of something being squared is whatever that something is, so it's just x plus delta x. When you're multiplying conjugates, the O and the I terms drop out. So this guy and this guy disappear, and now minus x. Negative square root of x times positive square root of x becomes negative square root of x squared, which is just x. All divided by? Plus square root of x. Good. Don't distribute, right? We want factors to divide out, so we're not distributing. Okay, in the numerator we have some simplifying to do. Right? Those add to 0. They're not a fancy one. They're not dividing out either. They just add to 0. Oh, next. Yeah. We have a delta x now only in the numerator and a delta x in the denominator. So what does this delta x turn into? 1. So I can make that 1, and then this guy is gone, right? Okay. So now I have, just to clean this up, the limit as delta x approaches 0 of 1 over the square root of x plus delta x plus the square root of x. Can I direct substitute now? Okay. Equals 1 over what? Yeah, this becomes 0, so I have the square root of x plus the square root of x, which is 2 square roots of x. That's f prime of x. Okay, so that's our derivative. We did, like part 1, find the derivative. We did. Now find the slopes of the graph of f at the points 1, 1, and 4, 2. So f prime at 1 equals 1/2. We plug 1 in here, we get 1/2. F prime at 4 equals the square root of 4 is 2. 2 times 2 is 4. You get 1/4. Okay, now discuss the behavior of f at 0, 0. What can we do? We're going to plug in 0 where? So before you do that, let me ask you this. Does the function exist at 0, 0? Does the function exist at 0, 0? Yes, it does. We can take 0 and plug it in here and we get 0, right? So the function exists at 0, 0. Now you want to plug 0 into f prime. So f prime of 0 equals 1 over 2 square root 0, which is 1 over 2 times 0, which is 1 over 0, which is undefined. That means that the is, so that's a vertical tangent line, okay? So the idea that we're talking about in the beginning is correct. The vertical tangent line right here is found mathematically by doing this. You can think about that vertical tangent line as being sort of a boundary, like a line that you can't cross, okay? This guy can't turn back around because then it wouldn't be a function anymore. Has that vertical tangent line there, vertical slope, the function kind of would go discontinuous there. It actually switches to imaginary. Like we can come up with a function that does something like that with a vertical tangent line there. But in this case, the function actually stops because it goes imaginary. Okay, so just something to think about there. All right, find the derivative of f of x equals 1 over x minus 1. We have that function sitting here. What do you see on this graph? We're going to have a vertical asymptote. Looks like about what? Coincidence that we have a minus 1 sitting here? No. Probably not. So let's just keep that in mind and let's find that derivative. Set it up. Good?
Minus 1 over
Good. That's f of x plus delta x minus the original f of x. And then all of that is all over delta x. So, yes, we need a common denominator for the numerator before we can simplify this. That's fine. What's my common denominator going to be? This is a factor. This is a factor. Neither one of those factors exists in the other. So that means this common denominator will be x minus 1 here. And then over here, x plus delta x minus 1. Again with the fancy ones. So now I have equals the limit as delta x approaches 0 of x minus 1 coming from this minus. Are you distributing or am I putting parentheses in? Okay, so we got the minus sign there. It's being distributed into this whole thing, so minus x plus 1. all divided by x plus delta x minus 1, parentheses x minus 1. All over delta x. Good. Okay, now the temptation here, the reason I want to talk about this problem is the temptation is to say, oh, well, I got an x minus 1 sitting here and an x minus 1 sitting here. How about I just divide those out right now? You can't do that, yeah. That's like saying 3 plus 4 over 3 would allow me to do that. That's a colossally terrible mistake to make. This is 7/3, and if you did this, you would wind up with an answer of, or 5, if you actually divide it out correctly and said that this is a 1, which most people don't. If they make that first mistake, they're likely to make the second and third mistakes. This is not true. Don't do that. Likewise, you can't do that here. Simplify the numerator. What do we get? The x and the negative x are gone. The negative 1 and the 1 are gone. So you're left with that negative delta x over x plus delta x minus 1, x minus 1, all divided by delta x. Don't multiply them out. You don't need to. How do I deal with this? Yeah, leave it, change it, flip it would be the shortcut. Basically, this is delta x over 1. So I'm going to leave this. I'm going to change this division to multiplication. I'm going to flip this fraction to be 1 over delta x. What happens? So that's basically what I have, right? The delta x's are gone. That's a negative 1 up top. So now I have limit delta x goes to 0 of what? Negative 1 over Can I direct substitute? Okay. Negative 1 over, this becomes x minus 1 times x minus 1, which is just x minus 1 squared, because we're multiplying. So that's the derivative. I just want to make a comment about that vertical asymptote there. We said we have a vertical asymptote at 1. If I plug 1 in down here, what do I get? I get an undefined slope, a vertical line, okay? So it is no coincidence, and we'll discuss this as the chapter goes on probably, and definitely in chapter 3, but it is no coincidence that you get an undefined slope when you have that situation there, okay? That's as much as I'm going to say on that. It sounds obvious right now, but there's more going on than just that. That's the whole section, I guess, so